Okay, so the next thing we're going to do is we're going to go through kind of how we can make this file setup right here turn into a Python file, and we can actually call this from Python. So I'm going to suppress this output for now because I don't want any of this to show, any of these print statements to show up, for now at least. Let me give an enter there. Okay, so the reason that this is written the way it is because I know how it needs to sit up for the output. So essentially, what we're going to do is we have to make variables that are external to the functions, the C functions. We have to make Python aware that they exist. So what variables do we have? Well, these we can pass in from Python. So I'm going to say pass these in from Python. But this is a C-based library. So that's going to be hard to pull into Python because we'd have to rewrite the whole thing, essentially. So we need to make Python aware of this function, this data type, this data structure. We need to make Python aware of this make audio session, this setup, and then this stream samples. Because essentially the main is acting as is what is externally visible to Python. So what I'm going to do is I'm going to start coding, and we're going to see why that happens. So what I need to do first is I need to make a container. So I'm going to turn my internet on. The library we're going to use for this is called Cython, and I cannot download Cython system-wide. So what I have to do is I have to install this as a container copy. So let's let the internet turn on here, and then I will show you how to do this. Where is my iPhone? Wow, I really can't find my iPhone today. That's crazy. I've never seen this before. Why can't it find my iPhone? Connect to iPhone. Jeez. Huh. Well, what I'm going to do is search on my phone, then how to set up an environment on Chromebook. Okay. So I need to type Python 3-m virtual environment. Let's call this my Python project. Then it's going to take a couple seconds, and it will. That really bums me out that I can't connect to the internet on my phone. Then it'll eventually come back and it'll be set up. Okay, so let's do a line search. So my Python project is here. So let's cd. Actually, we don't need to cd. What we're going to do is source my Python project /bin /activate. So I've done this enough times to know what we're doing. So from inside of this, I can pip install Cython. Well, if I can't connect to the internet, I cannot install. Like, it won't work. I need the internet to install, because what it's doing is the package manager goes to the internet and downloads the setup files and stuff. There it goes. All right, let's give it a reach. Let it retry. So then you can do Python install packages list, and it'll show you what packages you have. So you see my Cython is sitting there. That's great. So I have to do this because I am using this on a Chromebook, and it's a virtual environment, not a true environment. So what I'm going to do is copy and paste my C project into this folder structure. So let me do cd my Python project, line search, cd my C project, cd build, cmake. So this is interesting. This happens when you have the cache. A cache is just the storage of variables. So it says the current, like, everything in CMake is based off of a root directory. So what it's telling me is that this directory is different than the directory the cache was created. Right? You can see Nick Munson 22, my C project, whereas this one is Nick Munson 22, my Python project. My C project. So what I'm going to do is I'm going to go back one directory, I'm going to remove this build, and then I'm going to make directory build, and then change directory build. So now I can run a CMake, and it'll go through all of this. So it's got my port audio, it found all of these things. That's great. The sources are here. That's pretty good. That's perfect. Okay, so now let's do a make. Let's do a /my executable, and let's just let this go. I think the problem we're going to have is I didn't change the output directory from our save, so it's going to save somewhere else. But that's all fine. Okay, so let's go to our text editor and just close all these files, because I don't want to have anything open. Okay, so what we're going to do next is we're going to go here. My ChatGPT's been super slow lately. So what imports do I need for my .pyx Python file with Cython? Yeah, that's super slow for some reason. I'm just going to use this. What inputs do I need for my .pyx file with Cython? So, yeah, the imports change, blah, 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 blah. So we'll get through a lot of this stuff, but essentially, if you recognize these from what we just used, what we're going to do is we're going to basically create an interface for Python to interact with our C code. And this will make a lot more sense as we get deeper into this. So let me look at what I imported last time. No, that would be cheating. So import Cython, C import Cython. The first thing we should do is we should make a file for this. Let's do text file. Let's make a text file. We're going to save it in the directory that we just created. So let's put it in my Python project. Let's do audio wrapper.pxy. So pxy is a special type of Python file. It essentially works the same as a header file, and there's also a .pxd, which is the same as like the .h and .c structure. We're just going to use a .pxy because our project won't be that big, but if you need to write a very large wrapper class, then you do need that. And then I need to know what the command was to command for an in-place build and a simple setup file. So we also need a setup file. Python, sorry, we'll call it setup.py. Now what this does is kind of interesting. It'll look a lot like a CMake list actually. Oh, that's Yang right there. So let's use the command for the in-place build. And we're gonna run this from command line. So we have to run this from the place where this file exists. So setup.py. Let's just run this. Okay, so that's really good. This Python, it lets you run. Let me see if I need to use Python 3 too. Okay, it doesn't matter. So it's building the extension in place, meaning that it's gonna build in this folder right here. You can also give it a folder argument. So let me go ahead and get a better setup. Can I have a blank setup with the folder with the sources and libraries and such? So this is what it looks like on the surface. So it's essentially like a CMake list for Python. So first thing we have to do is edit the source file to be audio wrapper, because that's what this is our Cython source. It's literally the same idea as the CMake, except now we're using Cython to do this. So my libraries are port audio, comma, SND file. I don't really need this actually. And then this library dirs and the include dirs are the same thing we had from our CMake output. Essentially what we're doing when we call this, we're running the Cython setup to Cythonize this in air quotes. So what I'm going to do is I'm going to put my include directories here, and I need to know what those are, so I need to go to my C project, cd build, CMake, ... So my include directory is here. This is for my header files. USR to include, and then this one is the same, so I don't need to include it. And then this is the library file. So I don't think I need to include the .so, I need to include this folder. Path to the library directories, so it needs to know where these folders are located. Great. So the next one is actually, they're in the same folder, aren't they? So I don't need to do it more than once. Okay, so let's give this a try and see what errors we come up with. So let's go backwards one directory. So I wouldn't get overwhelmed by this tool. This tool is the same idea as learning a CMake list. You just learn this, right? Like, this is super simple. It's translating the CMake for Python to use. This is the idea. So let's go back through our commands. Extension is not defined. Extension is not defined. Let's figure out what syntax we need to use for this. And have this is what AIs are pretty good at, is error checking. Top of your extension. So from the setup, we also need extension. So there's a lot of things that are going to print out. Great. So it did it. What this does is these two files are sitting right next to each other. So if I wanted to adjust this, right, like I could have like a different folder, like maybe I put it in folder A. Okay, you get the idea here. But since it's in the same directory, it's going to start at the root directory, which is this directory that we're in. So home Nick Munson 22, my Python project. And what that does is it builds this .so shared object file. This is what we can actually import, which is really cool. So I'm going to go and change I'm going to delete this actually first. I'm going to delete this right here, because I don't want it to sit there. I want to change the name from my module to audio interface. I'm going to say audio interface package. And then let's run this again. Great. So let's look at what we got now. Audio interface. Perfect. So we're going to go back into here, and then this is where all the magic happens. So this is a Cython definition from config.h extern from. So anything that was in our main that's externally facing, we need to define here. So I'm going to go ahead and open up all of our just actually config and main, because the way we built that's why we built the program the way we did. So these, again, we can define in Python. This is externally facing. This function is externally facing, meaning that we need to call this in order to execute the flow of our data. And this is externally facing. So what we need to do is go to our header file, and we need to include basically the structure for Cython to translate to Python. So I'm going to go ahead and copy all of this to here, because I don't really remember cdef struct config params int sample rate int frame. Okay, I'm gonna copy and paste this at this point. That's too much. No, I'm not. That's hard to format. So you can see we're actually writing this in a very Python-like way. Int duration, int num samples. Then we're going to define the next one, cdef struct recorded data. Void pointer. One of the things that is recommended to do is to define these as void pointers, because C plus, like, Python doesn't care what kind of pointer it is, and if you want to define the pointer type, if it's not a standard pointer type like float, you have to do a lot of work to basically import your stuff here, and that's a lot of stuff. So audio session void stream config params recorded. So you'll notice that I didn't define the port audio stream because I don't want to have to deal with importing it as a Cython object. But I did define config params as a pointer because it's defined here, and I defined recorded data as a pointer because it's also here. So essentially what I'm doing is building a suitcase that Cython can pick up, right? Cython can run this function, pick up the suitcase here of session, because we've defined what session is right here for Cython, and it can take it to the setup stream and then take it to setup samples, or sorry, stream samples. Python doesn't know how to interpret this pointer object. It doesn't do pointers. It doesn't work that way. What it needs to know how to do, and what Cython does, is it needs to translate this into an object that Python can manage and pass to the next set of functions. So that's what we're going to do. So at this point, I'm going to try and compile this again, and then look for errors. config.h. No such file or directory. I wonder if it's because I didn't include this in my setup file with my include directories. It probably is exactly that. So let me go ahead and find this. cd my C project, cd sources, print working directory. So I need to include this directory for the Cython compiler to find. So let's see if that will fix my issue. But first I need to go way back. cd my Python. Perfect. So this, you include your directories to wherever the code is. So the code we were using is at user/include for port audio and SND file, and the libraries are named this, so it's going to find them itself, and then the libraries are located here, so it's looking for libraries at this directory named port audio and SND file, and you can see that it found everything it needed to compile this into a shared object. Perfect. So what we're going to do next is a little tricky. We're going to cdef a class called audio wrapper, and then we're going to cdef an audio session as a pointer as a session. That's crazy. Then we're going to do something very strange. At this point, these are Cython objects. And what we're trying to do is make, ultimately what Cython does, let me back up, is makes an object that's available to Python that Python can understand. So what we're doing is we've defined all these objects to Cython, right? These are the external objects that Cython sees. So what we're going to do now is define something that's available to Python. Init define, the syntax for an initializer is here. Self.session pointer equals. We're going to initialize the session pointer here, but I'm not going to do it yet. The first thing I'm going to do is print inside init so that I can figure out where we're at in this program as we run through things. Print inside, or finished init. I need to do this actually. Finished init. Actually, it doesn't matter. Okay. So what I'm going to do now is create a Python file that's called, save as, test setup.py. This is not syntax. This is just for a good name. .py. So what I'm going to do is import the audio wrapper. So let's do this. Python 3 test setup.py. No such file or directory. So where did I just save this to? Shit. Maybe I should go back here and close this. Did I save it to here? I wonder if I saved it in this source. Yeah, let me move that, because we need to. This is a lot like the main not the main, but the CMake and make we were doing. We have to run from the. Okay. No module named audio. Oh, because I called it audio interface. Duh. Okay. Let me open that Python file again. So, test setup. I didn't call it audio wrapper, I called it audio interface. Okay, that executes. What that means is that this can actually find this shared object file. Amazing. Now, what we're going to do is I'm going to actually put my pasta on the stove before all my water boils away. Ew, gross. Okay, so when I sit back down, I want to go through the process now again, because this is somewhat confusing, more than likely. This is a Cython file, and this setup is what compiles your Cython file into a .so or shared object called audio interface. So when you import this, right, this Python is looking for the audio interface portion, right? This is your module name, audio interface. And you can see where we set that, right? This is the name of our extension module. We included the source that we want to use, which is this. So this is literally a CMake list for Cython. And it compiles C code into a shared object file that Python can import. When you import a module into Python, what you're actually doing is looking for these shared object files, right? Like this. You're looking for this .so file, okay? So you see how when we wrote this header file, this is a library port audio.so. What this Cython does is it takes this .pyx source Cython file and it turns it into a .so shared object file. Python can import .so shared object files, and the way it does that is just with a simple import. What we need to do is we need to use Cython to make a class or module that Python can interact with. So what we're going to do next is continue adding to our class. So let's do this. Let's actually create an audio wrapper class from our test setup. Audio interface. Let me do this. Test equals audio interface dot audio wrapper. Audio interface has no attribute audio wrapper. It doesn't? That's so sad. It should. It should. Let me actually just do this. Okay, perfect. So that works. Where is my class? I might need to error check this for a second. Because what I should be able to do is say like audio interface. Audio wrapper. And then like execute this. How does it not have an interface audio wrapper? That's what this is supposed to be. I'm going to call it audio wrapper C, and then we'll build it again. Okay, so my problem was that I had named audio wrapper the same as my file, and it didn't know what to do because it found this and this, but that's not a shared object file, so it was very confused. Okay, so you see how what we've done, anytime you initialize a Python class, what you do is you run the initialization, right? And you pass it self, and what self is the set of internal variables that are aware to a Python class. So if you don't really care, like if you just wanted to say define print hey, and then I just did this, print hey. And then I went here, and then I compile this into a shared object file. What am I doing wrong? Define, what did I do? It has 0 declared. Oh, I have to pass self. This is a bad example because you always have to pass self in Python. In a Python class. But what I can show now is an example of like test equals, I'm setting this up to be a test class object. So this variable test class is an audio interface. In Python, when you import, it's module you import dot class or dot function or whatever. So what I should be able to do is say test class dot print hey, and it should do that. I should also be able to do this. These are really equivalent statements with test class taking the place of this. Okay, great. So let's go ahead and continue with this. The next thing we need to do is make the functions aware to Python. Okay, and the way we're going to do that is by opening, well, we have it open already. We're going to, no we don't, yes we do. We're going to, let's do the first one. We're going to do this. We first have to make Cython aware of this file. So Cython definition external from helper functions.h. So we need to Cython define this function. And then inside of this, we're going to set our session pointer. We're going to assign this output to this. Sample rate. And this is going to be really cool. But what we're going to do is we're going to pass these as constructor arguments to our function. And then what I'm going to do is take these so that we know what we need to pass, and we're going to define them here. So we need a sample rate equals 44,100. We need frames per buffer equals 256. Num channels equals 1 for mono. Duration equals 5. We'll just set that there. So then we're going to take these and we're going to pass them as constructor arguments to this class. Go ahead and compile the setup. Oh, what am I doing? I think I botched that. Okay, so there's a lot of warnings here, but it produced the shared object file. So there's a lot of warnings that'll happen with this, but if there's no errors, you are good to go. So let's run this. Import error, undefined symbol, make audio session. I wonder if I don't need to do it that way. I wonder if I do it this way. Cannot convert Python object to audio session, make audio session. Let me actually open up the other one I did to see what the syntax is for this, because I don't remember right now. Test Cython environment. Test wrapper.py. No. .pyx would be somewhere. C source. Where the hell did I put this? Oh, that is absolutely not what I want. That's just a bunch of gibberish. No. That's the setup. Let me search for .pyx on this file path. So let me remove this actually. Session pointer. Make audio session. I think this is actually right. Oh, I wonder if I didn't spell it right. Yeah, that's right. I spelled it wrong. So what this does is this makes the audio session function aware to Cython. And then here we create an audio session object to hold the output of this function. Now if I go to, essentially what this does is Python can't access this variable, but it acts as a suitcase to carry the information in an object format that Python can understand to the next set of functions. And the key is that these are accessible to Python. And we can use functions that are accessible to Python to move our C code through the steps it needs to execute. So let's run this. And I don't know if I need to change anything yet. Make audio session, undefined symbol. Oh, that's super weird. Undefined symbol. Make audio session. So I'd made this aware. That's weird. Let me ask for some help here. Maybe I need a CDEF there. Oh, I wonder if I didn't include my sources. Yeah. This, I also need to include my C sources. Let's go ahead and build this. There we go. It's now looking through all of my C code. So you see that this unsigned long ij is in, it's not in the helper function, it's in the source file. Let me get back to the right folder, my Python project. Yeah, so that unsigned long is in the source file, this .c file, inside of our stream, which is right here. Yep. So that's good. That should run now, actually. Yay! So if you look at this, what it's actually done is run the code to make our audio session, and that's pretty cool. So I actually think I have a spelling error now that I see that again. Yeah, look at that. That's crazy. Anyhow, so the last print statement it outputs is this function, right? So now I need to duplicate this process for all of these functions. So I need to make our Cython compiler that generates the shared object file aware of all of these functions. So let me do that. Let me do the next one, and then let me remove this because it doesn't know what to do with that. So then we'll call this define setup stream C, and then we'll say setup stream, and then this requires a session pointer, so we'll pass it self. We need to include self in all of our class functions because you have to pass the Python object variables to itself. Self.session pointer. So then let's put a print statement that says inside of setup stream self print finished setup. Oh my god, I didn't even close this. Let's go ahead and compile this file. Lots of warnings, blah, 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 but as long as it produces this last line right here, boom, all done. Okay. Great. Now we need to update our test, and we need to say test class dot. What are some functions we can use? So right now test class is actually like, test class is an audio interface dot audio wrapper C object. Then there's arguments in here. So what I can do is, like, this is also another point. This is how this works when you interface through stuff. So audio interface is the name of the module that we generated, right? Using this script, audio interface was generated using this script. So inside of this, it has access to these the Cython definitions. So audio interface was the produced module, and then we can dot into this, right? I've never tried to dot recorded data because it's a C object and you don't really want to do that. This is kind of the structure you follow to get your C information out. I wouldn't think too much about like trying to manipulate this because it's not really a manipulating thing. You're using this tool in the way that it's intended to be used, and no more and basically no less. Okay. So let me do this. Let's define another function, cdef stream samples, and then let's remove this. We're going to define stream samples C. I'm going to pass it self because we need access to this class variable, the session pointer, to pass it through the inside of stream sample C self. Then we're going to print a finish statement as well so we know where we are. So then what we want to do is stream samples self dot session pointer, and then we need to recompile this. So this is, we're going to compile our setup file into a .so shared object file, and then we're going to do this. Oops, I didn't finish this. So we can say test object dot what are the two functions we can use now? Setup stream and then yeah, so I think this needs to be called in a little bit of a goofy way. Which is an audio session pointer object. So what I think we need to do now is say like setup stream test class. Setup stream C. What did I call this? Maybe it's dot setup stream C self. Oh, shoot. Yeah, this is where this is kind of confusing, actually. So look at that. I've actually opened the audio stream. That's really cool. And then the next thing I need to do is test class dot. What's weird is like this may not be true, actually. This is an audio interface dot audio wrapper C class object, and when you call dot setup stream, you're actually passing the you're passing itself behind the scenes, and you're doing all of these things without the user being able to touch them. And the reason is because this is just an object, and you can't really manipulate this, right? Like I can say this. I think this will really get the point across. Let's do this first so that we get the stream samples C. Let's finish this out. Stream samples C, and let's do this. So there it goes. It's actually now streaming our samples for us, and that's pretty cool. That's really cool. So I think you can actually do this. Print test class dot session pointer. So it's going to do the stream, then we're going to print out our session pointer. So it has no attribute session pointer. Did we call it session pointer? We did. So this exists, right? This session pointer exists, but it's not accessible to us in Python. We're using this Cython as a tool to pass the audio session pointer in an object format that Python can understand to the functions we need to execute C code that has been compiled into, to execute C code. This Cython process is compiled using a setup file, which is very similar to CMake, except to the CMake list, except you're compiling as a Cython. Cython is compiling into a shared object file. I hope that's a good enough definition of what we're doing. Anyhow, so that's it. That's what we're doing. But one of the problems is now we can't really get this data we can't really get data off of this object yet. And that's what we're going to need to do next. So in the next part of this, what I want to do is talk about how we can actually get the data from our C project. So that's let me run this one more time with a good ending. All right, there we go. We're sampling from our Python module. We did it. Yay. Now what we need to do is, if you remember in the C code, we were able to just pull the data off of our session, right? What we need to do now is write some helper functions that take this data and actually return doubles and arrays, something that Python can handle. So that's what we'll do in the next video.